Welcome to the LibreOffice tips and tricks. Today I would like to show a calculation simulation of a biochemical reaction. The reaction itself will be described by the following equation. Substrate plus enzyme will produce the enzyme substrate, and it is a two-directional reaction, and from it we can regenerate the enzyme plus making the product. So this will be our reaction, what we are going to simulate. So we can describe the kinetics of this equation here with the onset, offset, and the production kinetics. So the onset will be, let's say, 0.51 per minute. The off will be 0.11 per minute, and the production will be 0.31 per minute. And of course we need a time frame, and the time resolution I suggest initially to get thousandths part of the smallest value. It will be in minute. So now everything is ready for the calculation, and here are highlighted the kinetic constants. These are describing the chemical reaction, and of course we can measure them, and then we can make simulation on our own reaction. And here is the production. Now you can see that I use names: key on, key off, and key production, kinetic constant values, and dt for time resolution, because it will make my calculation more easy, more smooth, easy to read. So we have the simulation time in minute first, and then the concentration of the substrate, enzyme, in the same order like in the reaction we can read things, and then the product. Okay, and after that I will modify them to make the headline for the changes, because we will make the calculation that after the initial values are given, we will calculate how the values are changing, and each time the next row will be calculated from the previous plus the change. So the initial time we will have, let's say, 20 amount of substrate, 10 amount of enzyme, no enzyme substrate, and no product. These are the initial values how we calculate. These are so-called the boundary conditions of the simulation. And now the time frame will be the initial time plus the previous time plus the time frame dt, time resolution. And this value I can copy down. We start from 9, we can finish around 209, 309. Okay, so now we have it. How the substrate is changing. From the reaction we can see that the substrate is decreasing with the first reaction. So minus key on. You can see as I start typing the kinetic constant, because of the name is registered, it is already suggested to me. It will be used from the first reaction, the kinetic constant of the production of the enzyme substrate plus the multiplication of the substrate and enzyme. It is decreasing the value, and in the reverse direction it is increasing the substrate direction. Key off multiplied by the enzyme substrate. Okay, so now you can see how the reaction calculation looks like. So the change of the substrate is in first forward direction toward the enzyme substrate and reverse direction toward back the dissociation to regenerate the enzyme and the substrate. Now how the enzyme calculation looks like. Similarly to the previous, minus key on times substrate times enzyme, as the first part is decreasing the amount, but it will increase as the dissociation of the enzyme substrate regenerate enzyme end product or enzyme and substrate. So we have two parts, the key off and the key product, and all these depend on the enzyme substrate concentration. Okay, now comes the complex. It is produced by the first one in forward direction, substrate multiplied by enzyme, minus it is dissociated in two directions, again key off plus key product multiplied by its own concentration. Okay, now you can see that the enzyme is produced like this, and the enzyme substrate depends on the same, but here it is decreasing the quantity, and the product is made with the production kinetics from the enzyme substrate. This will make the enzyme plus the final product. So as we have the change, we can calculate the second time values as the previous plus the change. So I will copy everything, and for example here you can see that the second point enzyme substrate concentration is calculated from the previous plus its change. So this is the reason why it is important to have the same structure of the headings for the change and the values, because this way it is very simple to make the calculation. Now we copy, we double click to the bottom and copy this, and now we have the values. I will select all to make a figure to show it. Oh, I created a long calculation. I would like to make the figure on top. Okay, scatter plot with straight lines. We have enough, we have 300 data points. So I will put it on top. Legend nice, look nice on the top. Okay, I will insert all the grid lines. Maybe in previous videos you have already seen that I prefer grid lines very much because they help reading the values, follow the equations and follow the changes. Whenever it's possible, I suggest, highly recommend to make grid lines. And now the titles, the x-axis will be simulation time in minute, and on y-axis we have the quantity of several things. We have 4 charts basically in one place. I would like to move it a little bit down to be able to see the chart on the screen. I will make it a little bit smaller to fit the screen. Yes. Okay. So now we can see how the simulation result is here, and basically this is the very beginning of the changes, and we see a very short slice of the biochemical reaction because of the very fine time resolution. It is 10,000th part of the minute. Maybe we can decrease it more, let's say 10 times. Oh, now you can see a typical curve. So the substrate concentration is decreasing, the enzyme concentration is decreasing, the enzyme substrate is increasing, and the product is coming here. So it is very nicely comes. 100th part, it already looks nice. And you can see that this region can be called a so-called steady state part of the chemical reaction when the enzyme and the enzyme substrate, the red and the yellow lines, are almost constant, and the substrate decreasing constantly with the same speed and the same velocity, and also the production seems to be constant. Now we can increase the time resolution, maybe 0.05, and now we can see the whole reaction, not only the almost steady state part, but how it is finishing. And you can see that when the substrate concentration is decreasing and when we are running out of substrate, only the enzyme substrate complex is driving the whole reaction. And finally we will get, when it is getting empty, we will get back all our enzyme, and this is the final production here on the green line. Thank you for your attention.